everybody. Have you ever wished that you could see all the packets going in and out of your NIC? Maybe you're trying to troubleshoot an application or your own network settings. Well, good news is there's an industry standard, awesome application to do just that. And maybe the best thing of all, it's completely free. So stick around, because today we're going to do the fast version of Wireshark. Most of the time you've got to wade through a lot of stuff before you can get to the fun part of a new topic. But today I'm going to try something a little bit different. I'm going to skip right past how to install and actually use Wireshark, and instead I'm just going to jump in and show you a handful of really cool things that you could do once you have learned how to use it. If you'd like to know how to actually install Wireshark, use it, and do these cool things I'm going to show you, let me know in the comments. Hit that like button. All right, for now though, I think it's time to get into it, and to help with that, time for Tiny Brian. Tiny bread! Okay. Ooh, it's pretty. Okay. Here's what we're gonna do. We are gonna load up Wireshark. Already got it installed on here. And super fast version here. This lets you capture traffic going in and out of your NIC or look at captures that someone has already done for you. For our purposes, we are gonna be jumping into a few captures I've already got on here. All right, so we can do things like look to see what types of traffic are already in your capture. So for instance, what amount of the traffic by packets or bytes is UDP versus TCP, or breaking it down to particular types of traffic. We can also see maybe what the most interesting conversations are or sessions are within a capture by looking to see basically what is the biggest session that's in there, the most data sent. Not always the most interesting, but often. By coming in here to our conversations and then maybe just sorting by bytes. And this can help us narrow down, like we said, which is the one that we want to focus on. We might also want to go in and graph our traffic, maybe to compare the traffic that we do care specifically about versus all of the background traffic. In this case, we've got almost nothing that isn't our primary thing that we care about, right? But we'd be able to at least compare those two things to see if maybe something else is eating up a whole bunch of the bandwidth that you care about. Maybe there's a particular download you were trying that was going slow and you want to compare it against any TCP errors that you got. Like before, we'd probably go want to find that file download first. And once we got it, we could go graph it. Now, what you'd be looking to do, like I said, is graph that likely in packets per second or packets per like tenths or hundredths of a second, and then compare, did you get any TCP errors over that amount of time? Now, you'd want to compare TCP errors just for that session, but I'm getting a little into it said I'd keep going fast. So that's what I've got here. Here is this like 90 megabyte download. We could change it up, like I said, instead of just one per second, maybe one per tenth of a second. Graphing per tenth of a second. And then as it finishes drawing out here, I'm going to change it up to make those TCP errors that I happen to know are here a little more obvious, because these little red bumps down to the bottom are the count of TCP errors. This cool log scale thing helps to magnify differences, and we say, oh, yeah, definitely. As the traffic is spiking up and down along in here, move that? Yeah, there you go. We're getting a bunch of TCP errors. So then you might want to go investigate that further. Yeah, and there's some TCP specific graphs that you can use to go look at the details of what's going on. Like, okay, cool, how many bytes were coming in per unit of time, and look to see if there are like flat spots in here. We already saw examples of that a moment ago. This sort of counting up the bytes as you're going through. And then once you want to know a little bit more about it, we already saw that there was those TCP errors. So maybe we'd see, And these weird green up there is actually telling us that the TCP window size of the device that was receiving the traffic, in this case, the server out on the internet, I guess it was uploading here, kept dropping its window size down. Yeah, my internet wasn't slow. The server I was talking to was slow and just couldn't deal with any more traffic. And I could see that based on this graph. Okay, this is generic TCP stuff though. Sometimes you can actually get application level information as well. In this case, it would have been HTTPS traffic from the look of it. Yep, 443 or 443. So we wouldn't be able to read into the details, but let me go change out for a different capture. Okay, this is one where I've got my home server over there and I was literally just copying a file off the Samba Share SMB over to my computer here. This is not encrypted data. So we could go look into the SMB, the calls there to see what the response times were. Yeah, and so here again, we can actually see that, like for get info, how our minimum, maximum, and average amount of time it took for reading the same. Now this is just a little home server running off spinning disks over there. If this was a proper NAS, I would actually expect things to be a little bit faster here. Similarly, we could look into DNS. It is very often the case that your DNS is not encrypted. Now, this totally saved my butt probably a year and a half, 2 years ago. At my house, I was having a problem where everything online seemed so slow, but that if I tried doing a speed test, it showed everything was just fine. And this was this crazy thing because clearly I was experiencing slowness. So I ran a capture, not this exact one, but still, ran a capture and came in here to check around and looked at the DNS response times. In fact, this capture was made around the same time. And I found surprisingly long waits for DNS queries. Yeah, what it turned out was that everything was taking probably at least or nearly a tenth of a second on average. This isn't that bad here because this is in milliseconds. But this is pretty terrible because the longest time here is about half of a second. Not great. But I had even longer delays at that point. And the thing is, when you go out to web pages, you're almost never opening up one session to that web server to load up the page anymore. Very, very likely you've got one thing that you're downloading that's sort of the list of things that are going to be shown on there, and a ton of redirects to a picture from over on this server in AWS, another picture from over there, some banner ads from over here. And so there's tons of requests that get made just for a single web page to load up. And that would also be a ton of DNS queries. And if every one of them was taking at least a tenth of a second, well, that's going to be pretty terrible experience you're going to have. Yeah, turned out when I saw my DNS was slow, I checked to see what it was, and my home router was actually set up to have itself act as DNS server for everything, just caching local copies, and it was pretty bad at it. I changed it to a different DNS server, suddenly everything was good. And I found it coming over here to that statistics, DNS, and query response. Yeah, tons of useful information in here. All right, we're going to switch out to yet another one. If you are getting deep into things and you want to understand some new protocol, like in this case, I set up a VXLAN topology through a bunch of virtual switches. Man, don't even worry about it, right? You're good, you're good. But I wanted to get my head around what the heck this whole VXLAN thing was. Well, one of the things that you can do is you can have Wireshark create a diagram of all those packets, those frames for you, so you can take a look at that. There we go, edit preferences, layout, packet diagram for thing number 3, rearrange. Yaha, cool, give me a sec. Awesome, and here's some VXLAN traffic, and check it out. Now I can see that whatever this random, packet is that was in my capture here, yeah, here's the Ethernet frame starts with destination and source and the type, and there it is over there, it's IPv4, and inside of that, there's the IPv4 header, and inside of that there's UDP, and inside of that there's this VXLAN header. And inside of that again is Now they're Ethernet and IPv4 and the whole original. We're not going to know a VXLAN class here, right? But like, to make it concrete, this is what's going on. This is the encapsulation of that protocol. Can be hugely helpful to wrap your mind around it by actually seeing those bytes laid out and what information is in each of those headings. And finally today, we're actually going to jump back to another capture real quick. Have a second. Here we go. This is that capture I told you about where I was literally copying a file from my little home server over to my desktop computer over here through SMB Samba. And give me a half second. Okay, here's the thing. When you do run some capture with Wireshark or something like it, yes, you are definitely getting all this information of who it's to and from and that header information. But you're also getting the entire payload as well. So when this capture was running when I was copying a file over through this unencrypted protocol of SMB, that means that the file I was downloading is part of the capture. And if you know that, and like I say, if it's not encrypted, you can then grab that file from inside the capture. Yeah, it looks like this one. And save. And sure, just get rid of this % thing at the beginning. And look, here it is. Yeah! Hypnotoad says Wireshark is cool, right? And this file was literally pulled out of the bits of data that were running across the wire on the computer I was capturing from. Now again, if this had been encrypted, the bits would still be there, but I wouldn't so easily be able to put them back together again. Not unless there were some very specific circumstances where I had the keys, either the private key off the server or the individual session keys off the computer saved. And that's pretty corner case kind of situations. All right, y'all, like we said, this was just a super fast, get you interested, almost like trailer for Wireshark and what you might be able to do with it. Hey, I am having a blast, y'all, and I hope you are too. Like I said before, if you like it, hit like. If you want to know more, let me know. We'll see you next time. I think we're going to need a bigger WAN. Wait, why do I hear legally distinct, ominous music? Hello? Ah! Hello. My name is Wireshark. I solve problems.